Adjacency matrices and adjacency lists. What is an adjacency matrix? Well, suppose this is my graph. Clearly, we can see that A is adjacent to B and vice versa. A is adjacent to D and vice versa. A is adjacent to C and vice versa. And B is adjacent to D and vice versa. However, could we represent this as a matrix? Well, for starters, since our graph has only 4 vertices, we're going to have a 4 by 4 matrix, with each row and each column corresponding to a vertex in the graph. Next, we know that A is adjacent to B. So what I'm going to do to my matrix is I'm going to go to row A, then column B, and set that value equal to 1 to indicate that A is adjacent to B. Now we also know that vice versa is true, that B is adjacent to A, because this is an undirected graph. So we go to row B, then column A, and set that value equal to 1. Next, A is adjacent to D. So we go to row A, column D, set it to 1. Vice versa is also true. So go to row D, column A, set that value equal to 1. Next, A is adjacent to C. So go to row A, column C, set it to 1. Vice versa is true. So go to row C, column A, set it to 1. Then B is adjacent to D, so go to row B, column D, set it to 1. And then lastly, D is adjacent to B. There's an edge going from D to B, so we go to row D, column B, then set that value equal to 1, thus completing our matrix for this graph. What is an adjacency list? Well, let's use the same graph that we just got finished using, and now we're going to have, this time, a single array, a one-dimensional array. And it's going to be a size 4 because our graph has 4 vertices. And each value in that array will correspond to a vertex in the graph. Now, what kind of array is this, you ask? It is an array of linked lists. Right? And the linked list for A will store all vertices that are adjacent to A. The linked list for B will store all vertices adjacent to B. The linked list for C will store all vertices adjacent to C. And the linked list for D will store all vertices adjacent to D.